This video is for section 13-1 about arithmetic progressions, and it starts chapter 13 about progressions. A progression is a sequence, which in math is an ordered set of numbers. A sequence has a first element. You might refer to that as the first term in the sequence or the first number in the list. And each member has a successor, a next element, meaning that after the first term, there's a second term. After the second term, there's a third term, and so on. A sequence, also called a progression, is a list of numbers. The set of natural numbers is a sequence. We learned about the natural numbers in chapter 1 this year. The natural numbers begin with 1 and then count upwards, 2, 3, 4, and so on. Here's the definition of a sequence. The word sequence used in algebra refers to the values of any function whose domain is the set of consecutive natural numbers. A sequence is made out of numbers or terms. The terms are each of the values of the sequence. Terms are also called elements or perhaps members. Here's an example situation. A storage system is built from units. The first unit provides 8,000 cubic inches of storage, and each additional unit that you buy and you add to the storage system provides 4,000 cubic inches of storage. This table shows the values of function v of n, which represents the volume of the system with n units. So a storage system that has only one unit in it can hold 8,000 cubic inches of space. But if you buy that extra unit, and now it has 2 units, it can store 12,000 cubic units. With a third unit, it can store 16,000 cubic inches, and so on. Instead of listing using ordered pairs, the same information can be given in a sequence, which is a faster way to give information than ordered pairs. The sequence would be 8,000, 12,000, 16,000, and so on. The consecutive terms differ by 4,000. The position of the term in the sequence corresponds to the first coordinate in the ordered pairs. For example, the first number in the sequence is 8,000. That is associated with the ordered pair 1, 8,000. First number in the sequence, here, n value of 1. Let's add one more column to our table so we can write an algebra expression for v of n. In this last column, you notice our expression. The initial value is 8,000, and what's happening from term to term is we're adding 4,000 times n minus 1. The general term, also called nth term of a sequence, is given by this formula. With the general term, we can figure out the value of any term within a sequence by substituting an appropriate number in place of n. One type of sequence is called an arithmetic progression. This is a sequence in which the difference between consecutive terms is a constant number. We'll refer to that constant number with the letter d. In general, this symbol, t sub n, represents the nth term of an arithmetic progression, and the letter d is going to represent the common difference between terms. If you ever see the letter A in our math book, in the section about sequences, then that represents the first term in the sequence. So this formula right here is going to be really handy for you. This formula finds the value of any term based upon the first term and the common difference. Here's an example. Find the 17th term in the arithmetic progression 2, 6, 10, We want to find the 17th term by using this formula that finds us a term, instead of taking the time to actually continue this out 17 times. The formula to get the 17th term is t sub 17, that symbol means 17th term, equals A is the first term, which is 2, plus, and then in parentheses, n minus 1. If we're doing the 17th term, then n is 17, times d. D is the common difference, the difference between terms. From 2 to 6, that difference is 4 units. If we work out this math formula, that will find us the value of the 17th term. So it's 2 plus 16 times 4. That makes 66. So this formula finds us the value of any term we want, as long as we know the first number in the sequence and we know the difference between the terms. A finite sequence is a sequence that ends. It has a last term. An infinite sequence is a sequence that never ends. It doesn't have a last term. An infinite sequence would be a list of numbers where you end the list with ... to show that it continues forever. Here's another example problem. Write out the first 4 terms of an arithmetic progression if we're told that a equals -4. Remember, that means the first term. And we're told that d is equal to 10. Remember that d is representing the common difference. How it's changing from term to term. So we're supposed to write the first 4 terms. Well, what's the first term in the list of numbers? We're told that it's -4. What's the next term? Well, we're told that the difference between terms is 10. So -4 plus 10 is 6. 6 plus 10 is 16. And 16 plus 10 is 26. Here are the first 4 terms of that progression. Next example, find the nth term of an arithmetic progression if we're told the first term and we're told the common difference. To get the nth term, let's use the formula for that. It was t sub n equals a, so that's 5, plus n minus 1 times d. Well, d is -4. So this equation right here is the formula for the nth term. You can leave it like this, or you can take the time to write 5 minus 4 times n minus 1, which in turn is equal to 5 minus 4n plus 4, which is equal to 9 minus 4n. 9 minus 4n is the simplest version of the formula for the nth term. And now the last example. Find the 56th term of this arithmetic progression. -3x squared, -1x squared, 1x squared, and so on. Do you recognize how it's changing from term to term? Every term has an x squared in it, and the coefficient is increasing by 2. From term to term, it's increasing by 2x squared. To find the 56th term, we can use the formula t sub n, where we're using 56 for n. So t with a little 56 in the corner means the 56th term. It's equal to a, which is the first term, plus n minus 1, but n is 56 when we're talking about the 56th term, times d. d is how it's changing from term to term. We noticed it was changing by 2x squared. Let's simplify on the right side. We have -3x squared plus 55 times 2, which is 110x squared. This makes 107x squared. So using formulas, we're able to get the 56th number in a list of numbers without taking the time to actually write this out 56 times. Let's summarize the lesson. We started to discuss progressions, which is another word for a sequence or a list of numbers. But the one kind of progression that we focused on in this lesson was an arithmetic progression, a list of numbers where there's a common difference from one term to the next. The formula that's going to become helpful for you is this one right here. This finds any term that you're interested in if you know the first number in the list and the common difference between terms.